So these Aprilaire dehumidifiers, E100, E80, and so on, they are accessible parts-wise to work on. Things can go wrong, and Aprilaire has made them fairly modular to repair. So you can use the same Torx bits that you put the collars on with to remove the side panels. Just screws that kind of go all the way around. You pop that off. There's a piece of insulation that kind of sits there on each side. But there are problems that can come up with these things. This one has an error code and was kind of glitching out. We had a fresh air module connected to it, and we couldn't quite figure out in the field what was going on. So I'm going to try to figure out what's actually wrong with this thing. But yeah, I mean, once you pop the door off, from one side you have access, pretty good access to the compressor and the blower. You can see both coils. And then from the other side, obviously, the metering device, control board, transformer, capacitor, and a relay. So it is possible. There's a thermistor too. It is possible to work on these. So you don't necessarily have to throw them in the trash when something goes wrong with them, because it may not be anything all that complicated. So here's what we know so far. The E7 fault code generally relates to thermistors. With these units, you have two thermistors. You have one that connects to the coil and one that connects to the discharge of the compressor. They're actually labeled. When I test the sensors unplugged individually, they test normal with a resistance chart. But where they plug into is what's interesting. One of the ports, when I check ohms across the connection point to the board, reads vastly different than the other. One is reading like 4.5 k ohms, the other is reading like 30 and some change k ohms. So my assumption is the connector for one of these is messed up to the board, but I don't know which one. So, but this thing's relatively simple. I mean, transformer feeds low voltage power into the board, from the board up to the controller to get your screen to light up. You got a capacitor, split capacitor, a fan relay. You got line voltage coming in, it branches off, feeds line voltage to the board for the fan, line voltage to the board for the compressor, neutral for a fan compressor. Compressor power comes out through these to feed power to the compressor, and then fan power comes out through these to feed power to the fan. There's really not much else going on with this. But yeah, I think the board is messed up, but I'm probably going to try to pop the board off next and see if I can see any damage to the pins, because at this point I'm fairly sure thermistors are good, but something tests very odd with one of these ports. I think it was this frost port. They're even labeled frost and high temp. So I did try switching them, because they're the same type of sensor, and it's in a room that's a constant temperature. It made no difference. So it's definitely not the sensors. Wiggling it did not get the E7 code to go away. Okay. So what have we learned? If you disconnect the thermistors, test them to a 10 k ohm chart, they test normal. If you test the pins across the board, each one being labeled, okay, you're gonna end up with a different 10 k ohm reading for each. Okay, one of them was reading about 4.5, the other one was reading about 30 k ohms. This would trick you into thinking that the board is bad because these are reading differently. Now, the board is bad, but that's not exactly why. Each connection point has a reference resistance reading that it goes based off of with the board. You know, the high temperature thermistor, which is usually plugged into the discharge of the compressor, is in an environment where the temperature is always much hotter. So the reference resistance will set it to be kind of in range. And then obviously the frost sensor, which is in a much colder environment, the reference resistance is going to set it in a different range. So the fact that you read a different resistance value across these two does not necessarily indicate that the board is bad. But the board is bad because our thermistors are good, our wiring is good, and the biggest factor is the E7 code pops up as soon as you apply power to this thing, right? So it doesn't give anything a chance to happen. Okay, it doesn't let the fan kick on to sample, the compressor doesn't operate, E7 pops up immediately. So what that's telling us is the board logic right away is not interpreting good input from one or both of these thermistors. So, you know, the board powers up, it's looking to see a resistance value that makes sense. The thermistors are providing that correct resistance value, but the board is not interpreting those resistance values correctly. So ultimately, the board is the issue. Now, looking at the back side of the board, there's nothing that kind of stands out as being an issue. You don't see any burnt spots. You don't see anything strange or out of sorts. There's no wires rubbing. There's no wires touching. There's nothing obvious on the front side of the board. None of these capacitors are burnt. Nothing strange at all. So something internal of this board is not seeing the inputs correctly.